And this will be my last talk in this series of debugging talks and debug feature talks. And for all of you who have not followed me through all my talks, my first talk was generally about debugging, why it's a good idea for you to have a embedded debug setup. My second talk was like an hour ago about RTT, which removes all the I/O overhead on your embedded target that you usually have if you have a standard printf implementation. And now we will continue on this route and look, okay, how can I use this, for example, RTT technology to have some advanced debug techniques with it, which would, for example, be software instrumentation, where you can then extract some software tracing data from your target. So this is my talk, instrumenting an RTOS with system view, which would be the instrumenting software we use in a sample here. So what will we talk about? I will generally explain what code instrumentation is and why it's a great thing. We will have an example setup how this could look like, what kind of software you can use for this. We will see the features of such code instrumentation, and we will have a conclusion and a little sample so you can see how this looks like in the tool. So yeah, what's code instrumentation? In short, it's software tracing. So you use the target application software that you're running on your target to gather information with the application that is running there. The easiest bare metal example would be a printf, where you write, I made it until here, I made it until here, I made it until here. You did software tracing. Okay, so this is already on the basic level software tracing. The more sophisticated way would be to have some kind of API and standard or event handlers where you instrument your interrupt calls, your task switches if you use an RTOS, or function calls, your callbacks and stuff like that. You print maybe some terminal messages to complete everything, and then you get a deeper insight in your system. You can then have kind of a measurement of your application that is running on hardware. It can be essentially used on anything that runs embedded software, so there are really no limitations there, but you have to keep in mind it has always an impact on your real-time behavior because you do it in software. So this instrumentation software that you inject in your code, it uses some CPU cycles. But if you remember my last talk an hour ago with RTT, you can minimize this a lot, which I will also show. And I put this picture here of an oscilloscope because I like this as a comparison to the hardware world, because I think this is the perfect explanation of what code instrumentation is on the software side. Because if you use an oscilloscope to measure your hardware setup, you measure your timing domain, your voltages of your signals there. You also have some kind of oscilloscope, and you have the probes, and you go with your probes into your setup, you measure something, and you get also a great and deep insight in your hardware that you have there, but also at the cost of these probes that also can alter the behavior of your hardware, right? So, and here it's also important to think about it with these probes. This is kind of the I/O interface that you have in software, and it's very important to use high quality probes, otherwise the disruption on your target will be too high. So this is something to keep in mind, to use high quality probes or high quality software in this case. So yeah, the benefits of such code instrumentation, as I said, you can do performance analysis, code coverage, code profiling, all without extra hardware, so all within your software. It helps you to gain a deeper insight in your system to see, okay, where I'm wasting cycles, is everything working as expected, and yeah, no extra hardware, so no extra cost from a hardware perspective. And this would be an example setup. So for instrumentation software, for example, you can use System View. There are also other software. You can also write your own tools. In the end, you just need some way to extract your instrumentation data from your target to your host PC where you do the analysis. So it can be your own implementation. It can be software that's already on the market. For an RTOS, I also use something that I'm familiar with. It's emBO. Don't confuse this with emBO. Yeah. We had this name 20 years earlier, so yeah, and the method for data extraction will be RTT that I showed like an hour ago. And here's a little picture of System View. The next one shows this more zoomed up. I will show this also in software on this tablet running live, so you get an idea how this looks like and what information you get here from instrumentation. And this is how such instrumentation can look like, because usually what I often hear is okay, instrumentation sounds great, I want to use it in my software, and okay, I got this I/O impact on my system eliminated because I'm using RTT, but it's such a hassle to instrument all my RTOS or my Superloop application or whatever you're using. But the thing is, if you do it cleverly, it's not a lot of code that you have to add. And I think with System View, we did it cleverly, I hope. People like to use it, so I guess it's true. And as you can see here, for example, these are two examples. One would be a more complex instrumentation part, one would be a simple one. And one of the more complex instrumentation parts would be where you have, for example, your OS create task, a function, where you have your OS specific code, where you do the whole task creation, stack allocation, stuff like that. And the remaining code here is everything that needs to be sent out as an event, so you get this information to your host PC. So it's just some task name, priority, task ID, where's the stack, and you send it over. So that's all that's needed. So it's not really complicated, and this is one of the most complicated instrumentation brackets that you have to do in your RTOS. So, and everything else are usually one-liners. So whenever you have an interrupt for enter and exit interrupts, it's just one line. So you have your code that you had before, and you just add one line, which is the extraction of this data. So it's very easy to use. And when you are using emBO, for example, the big benefit is it's already included in the RTOS itself. So when you use a debug build of emBO, you just have to open the System View software and it starts recording. If you have other RTOSes, we also have patch files for this. So if you have, there's a list, some of these RTOSes, from third parties. We have patch files that come with System View for free, so you can simply patch your RTOS source with this, and your code is instrumented within minutes, and you can start recording. We have 3 modes for recording this data. We have a continuous mode, which uses the background memory access function from, for example, ARM Cortex-M targets. We have we can capture tasks, interrupts, timers, anything that happens on such an embedded system. So there's really no limit. You can instrument anything. The supported interfaces that we have for System View is RTT, but you can also use UART or over Ethernet, over IP. If you're a hobbyist or you use this for educational projects, it's also free to use, so there's no extra cost here. And it's multi-platform, which I think is a great thing these days. So yeah, conclusion, and I will then come to the little sample. All in all, I think code instrumentation is a very powerful tool. It gives you very deep insight in your application. You can analyze it. You can even save this data and use it in your test setups and say, okay, this is how it behaved back then. How does it behave now? You can use it also in maintenance. We also have customers that use it then on their production hardware and then say, okay, something is running weirdly, and this is now built in some gigantic machine where we can't access the debug port anymore, but we have implemented it over, say, over IP, so we can connect this big machine to some kind of network, and then we extract this data over the network. So it's also something that would work. And if we use, for example, RTT for this data extraction, we have a minimum impact on your target system, which would be, again, back to this analogy of the probes, I think one of the best quality probes that you can use. So let's come to the little example. So you just take a look how system view looks like. If you want to see a live recording, I have one prepared outside at the booth, so you can simply visit me and we can take a look. So this is how system view looks like for an example recording. So when you start it up the first time, we load up a sample recording that we did for, I think it was some Ethernet application. Yeah, we have some Ethernet tasks, IP task, a web server, and what we can do here is we zoom out and we see the whole recording here. When we, there we go. When we zoom in, we see task switches. Let's say I want to see when the next Ethernet task switched, so we see it displayed here. We see how long it took for each task to execute, how long the scheduler took, what is the CPU load at each point that you're referencing right now. Then you have the whole event log, some other information like your general run counts of your functions, and everything that was extracted by this code instrumentation essentially. So yeah, as I said, if you want to see a live demo of this, we have one prepared. And yeah, thank you for your attention, and this is instrumentation. Thank you. Questions? Yeah.
How much work is it if I am an author? How much work is it to add instrumentation hooks for your tools?
To a new application or whatever you mean? Or
yeah, no. If I write a scheduler myself,
okay, yeah. See,
how much instrumentation work am I going to be facing to?
Well, for the scheduler, it's just enter exit scheduler. We have API calls for that. Yeah. We have. I just showed two examples, but the scheduler instrumentation would be the smaller one.
Yeah. No, sorry. Okay, so now that I asked a stupid question, people can be less shy.
There are no stupid questions. That's fine. Okay. Yeah.
Also possible to log custom events.
Yes.
Like you make a call to a special function and you want to monitor
this. You can essentially customize. Of course, on the terminal you can print anything, right? And you can also customize here what gets printed here, because you're in full control. You have the source, right? We give you the source code. You can print in this buffer whatever you like. The software will display it. Yeah, and if it makes sense or not depends on how you write it into it, right? But if you use the API as described, then it will look like this, and you have a great analysis tool. And as I said, it also works with non-RTOS setup. So if you just have some super loop application, you can also instrument this without any issues, and you can also fake task switches this way. So you simulate a scheduler, because you don't have a scheduler, right? But you can still display it this way with your callbacks and stuff like that. So this is also possible, and we also have samples for this non-RTOS implementation on our Wikipedia site. So there you can just download it and have a guide how to do it, and yeah, I think it's quick and easy. Okay. Great. Okay, no more questions, then thanks again, and great talk so far. Thank you guys.